All right, so yesterday, not yesterday, day before yesterday, we did the probability distributions. So today we're going to talk about a specific kind of probability distribution, which is a binomial distribution. All right, so you need to, probably on your green sheet, write the following information down. What is a binomial experiment? And it is important to note what all the variables represent here, because we're going to be pretty much using them in every problem today. So a binomial experiment, first of all, has n trials in the experiment. And each trial will either be a success, which we're going to use an S to represent, or a failure. So we're looking for one thing to happen and one thing to happen only. If that one thing happens, it's a success. If it does not happen, it is a failure. The probability of success in a binomial experiment is constant from one trial to the next. So if you do not have the same probability from one trial to the next, it is not a binomial experiment. You must have the same probability throughout. The probability of success is P, and the probability of failure is the complement of that, Q. All the trials are independent, and X is your number of successes. All right, so N, P, Q, and X. You need to know what each of those represent. I'll give you a couple minutes to get it all written down. Okay. All right, so on your paper, let's do an example of a binomial experiment. In this experiment, it consists of picking a card and determining whether or not that card is a club. So we're looking at one thing and one thing only, whether or not it's a club. If it's a club, it's a success. If it's not, it's a failure. And then we replace the card each time. Replacing the card each time is important because that means that we're going to have the same probability throughout. If you did not replace the card, you do not have the same probability throughout, so it is not a binomial experiment. All right, so the first trial was run, the first card was picked, and it was a 10 of spades. Is that a success or failure? That is a failure. The next card was a 9 of clubs. Success or fail? 8 of hearts. 5 of diamonds. Jack of clubs. Success. All right, find N, P, Q, and X. N is the number of trials that were run. How many trials were run here? 5. P is the probability of success on each trial. So every time I pick a card, what is the probability that I will get a club? 13 out of 52, which as a decimal is 1/4, 0.25. Q is the probability of failure, not getting a club in this case. So if the probability of getting a club is 0.25, the probability of not getting a club is 0.75. Remember, you can just do 1 minus P to get that Q. It's always going to be a complement. Last but not least, X is the number of successes. How many successes were in this trial? 2. Questions? Finding those variables. Okay, the next set of problems on your paper are the following. You first want to determine whether or not it is a binomial experiment. If it is not, say why not. If it is, you're going to list N, P, Q, and all the possible values that X could be. So the possible number of successes that could happen within that experiment. There will be more than one answer. All right, go ahead and try them. Talk about them with your group, then we'll put them up. Okay. When you're ready. Here, there we go. Answers. Make sure you include 0 for your X's. There could be no successful surgeries all the way up to 8. The bottom one is not a binomial experiment because we are not replacing the marbles. So the probability is changing with each trial, with each draw of a marble out of the bag. The jar, I guess. Okay. Any questions on either of those? All right. Okay. So now let's say I wanted to know what the probability is that when we do this surgery, exactly 3 of the surgeries will be successful. Okay, so that can happen a lot of different ways, right? The first person and the second person and the third person, or the first and second and fourth, and then we can find all those different combinations of the way that 3 people can be successful, and then we want to find the probability of each of those, 0.85, and then we multiply them all together. That can get kind of complicated when you have really large numbers. So we use the binomial probability formula. Now, the condensed version of it is the one on the left here, which is the one that I would write down. This guy here. What you see on the right is they've just written out that combination formula we learned about in the last chapter. N choose x, and then you do n factorial over n minus x factorial times x factorial. Okay, but we'll really just be using this one. We're going to use our calculator quite a bit for this. So we're going to do n, the number of trials, choose x, the number of successes. Then we're going to multiply that by our probability of success to the power of the number of successes we want, and a probability of failure times the number of failures that we want. And those two things will add up to n. So example at the bottom here, it says there's a 40% chance of rain for the next 3 days. What is the probability that it will rain exactly 1 day? So you want to start by naming n, p, q, and x like we practiced. What is n? The number of trials. 3 days, yep. Probability of success, the probability of rain. 0.4. Q, the probability of no rain. 0.6. And X, how many days do we want it to rain? 1. So the formula looks like the following. 3, choose 1. N, choose X. Then we're going to multiply by the probability of success. And we want 1 success. Probability of failure. And we will have 2 failures. Those exponents should always add up to n. You can do this in your calculator now. Okay, so, or you can do it by hand if you want to use the factorial formula, but calculator is probably going to be easy when they get a little bit larger here. So remember that combination formula is under math probability in your calculator. So 3 choose 1 times 0.4 to the first times 0.6 squared, and you should get 0.432 is the correct answer. Good? Okay, now let's say I didn't use this formula and I wanted to figure this out by hand. If I wanted to figure it out by hand, it would look like the following. And this is just for 3 days with one thing happening. Imagine if we had larger numbers. You would make a tree diagram with day 1, day 2, and day 3. So these are all the different things that can happen here. It can be sunny 3 days, it can be sunny and then rain, it can be sunny, rain, sunny. And then we find the probability of each of those by multiplying the probability of all 3 pieces together. Then we would have to find all of the different branches of our tree diagram that have exactly 1 day of rain. And then we add up all their probabilities, and that gives us that 0.432 at the bottom. Okay, same answer, nice visual, takes forever. Okay, so this is what it's doing for us. It's figuring out, well, there's 3 different ways for it to rain on 1 day. It can rain on day 1, can rain on day 2, can rain on day 3. Each of those have the same probability, 0.144, and then we're adding them up. All right, try this one on your paper using the binomial theorem. N is 5, P is 0.25, we talked about that earlier, probability of getting a club out of 52. 75% is our Q. 3 successes, 3 clubs. So 5 choose 3. 0.25 to the third for 3 successes. 0.75 squared for 2 failures. 0.088. Yes.
So for the how you got the 3 to put over like for the power,
Mm-hmm.
you could just get that because of the x.
Yes, that is always going to match. This and this should always be the same. Okay. Other questions? All right. On your green paper, there is a table on the very back. You guys find that? So that table is all of these calculated for a bunch of different probabilities and a bunch of different trials and successes. If you want to use that table, that table is only for every 5% probability. So like if your probability of success is 12%, you wouldn't be able to use that. But in this example, I have 10% success rate. 10% of workers in this case in the United States commute to their jobs by carpooling. You randomly select 8 workers. What is the probability that 4 of them carpool to work? Okay, we're going to use the table just to answer this question. What's N in this problem? 8. What is X? X is 4. And what is P? 10%. So 0.10. Okay, on your table, at the very top are your probabilities. So I want you to find 0.10. On the side are your N's and X's. So you're going to go down to where it says N is 8. And then below that, it'll say 0, 1, 2, 3. We want X is 4. And where those intersect will be your probability. No, it's tiny, but what did you find? 0.005 is correct. Okay. So if you have increments of 5%, you can use the table as long as it's within, like, what does that go up to? 7, 8, 9, something like that at the bottom? That many trials? Okay. Questions on that? Moving on. All right. Let's say we want to make a binomial distribution. A binomial distribution accounts for all the different possible values of x, like that surgeon problem that we saw a few minutes ago, and the probability of each of those successes. In this case, it says a survey. U.S. adults are asked to identify whether they are on a certain social media platform. The results are shown in the figure below. 6 adults who participated in the survey are randomly selected and asked whether or not they use the social media platform Facebook. Construct a binomial probability distribution for the number of adults who respond yes. All right, so there's extra information here, first of all. Remember, you're only allowed to have one question in a binomial distribution, and the answer is either yes or no. And the question in this one is, do you use Facebook? Yes or no. So that is the only part of this that we are concerned about. So what is our P in this problem? Probability of success. Probability they will say yes. 0.68. What is our Q? Probability they will say no. 0.32. What is our N? 6 people. And then we're going to look at all possible values for X and find the probability of each of them. So what's the lowest possible X value that we could have? 0. We could have 0 successes. All 6 people could say they are not on Facebook. And it can go all the way up to 6. So that's the top row of your table there. Okay, now the bottom of the table, we're just going to use the binomial theorem. And I'm going to do one by hand, and then I'm going to show you how you can do a shortcut in your calculator with this, because you have to pretty much do the same thing over and over again. So if I was going to do it by hand for 0, here's what it would look like. I would do 6, choose 0, because I want 0 successes. 0.68 to the 0 power, and 0.32 to the 6th power. And then you can type that in. So go ahead and do that real quick. 0 successes, 6 failures. I got 0.001. Yeah? Okay. All right. Shortcut in your calculator. If you don't want to keep doing that over and over again, which you can use the previous answer in your calculator if you want and just keep editing the numbers. Where'd my calculator go? Disappeared. Go to y equals in your calculator. Oh, never mind, wants to load up there. Nope. There it goes. Okay, and we're going to type in all the different possibilities. We're going to use an x instead of the individual number 0 that we used in the last one. Okay, so first I need to bring up my combination. So I'm going to go into math, probability, number 3. It'll show up in my y equals now. So it's 6, choose the number of successes, which is x. That number is going to vary. Okay. Then the probability of success, 0.68, and that is always to the x power. Probability of failure, the exponents always add to what? They don't add to 1. Look at the last one we just did. They added to 6, which is n in this case. Okay, so in general, they add to n. So if x is my first power and 6 is my n, 6 minus x is what's left over for the failures. Okay, and those two add to 6 then. So it takes a minute to type in. You might want to put this on your paper, by the way, so you remember how we type this in. But now if you guys go to table, it'll do all the probabilities for you. And you can see it doesn't have any answers below 0 and bigger than 6 because it's not possible to have any combinations if your n is 6 beyond those numbers. So then you can fill your table out really quickly. Okay, so probably on your paper, write down how you type that in y equals in your calculator. I will do that. Move that guy over so I can see it. Everybody get that okay? What do we have? 0.014, 0.073, 0.206, 0.328, 0.279, 0.099. And what do all probability distribution tables add to? 1. So you can double check it that way as well. Okay, good. Questions? All right, I want you guys to try the next one on your paper now. You can do it by hand if you want, or you can use it. Do it with the calculator, or a little bit of both if you want to try both. Okay, so here you are figuring out the probability of 2 successes, at least 2 successes, and fewer than 2 successes. So you might have to do multiple probabilities within one piece. I'll give you a few minutes. And you're ready. So I wrote it out by hand how you would do all the calculations, but you could have used the calculator if you wanted to use table of values, especially for ones like this where you had to add up multiple probabilities. So your n is 4, p is probability of success 0.17, so probability of failure 0.83. This is what it looks like for exactly 2. If you want at least 2, it's got to be 2 or 3 or 4. So you have to find all 3 probabilities. And again, this is where the table can maybe give you a little bit of a heads up or a little bit of a shortcut there on the time. And then the word or, remember, means we are adding. That's our addition property. Okay, if we see and, that's when we're multiplying them together. But or means add. So you get 0.1368 approximately when you add those together. And then you could have done a little shortcut on the bottom one. fewer than 2 is the complement of at least 2. So you can just do 1 minus the previous answer. Or you could have done the probability of 0 plus the probability of 1 and added those together, and you should see the same answer in your paper. So either one's fine. But I always look for those complements if I can, because it saves you time. What questions do you have there? Anything? Give me a second to correct it, and then we've just got one more quick little slide. Okay. All right, last slide. If you have a binomial experiment, binomial distribution, you can find the mean, variance, and standard deviation of it. Now, here's the good news. When we've done mean, variance, and standard deviation before, it involved a giant table of values and lots of columns of calculations with deviations squared and all those things. You do not have to do that for this. They're very quick, little easy formulas. If you want to find the mean, you just do your n times p. The variance is n, p, and q multiplied together. And then, as usual, the standard deviation is just the square root of the variance. So we'll do this one quickly here. It says, in Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. We're going to find the mean, variance, and standard deviation for the number of cloudy days during the month of June. And then we'll determine if there are any unusual values by interpreting the results. So find your important variables here first. What's n? How many trials are there here? Well, if it was for the whole year, yes. June. 30. Gotta sing the song, right? You guys know the song? The knuckle thing. 30 days has September, April, June, and November. When short February's done, all the rest have 31. Okay, all right. Okay, that's just me. I know the song. All right. Probability of success. So probability of a cloudy day. 0.56. Probability of it not being cloudy. 0.44. Okay, so mean, mu. We're just multiplying n times p. 30 times 0.56. Which gives me 16.8. Then variance, little mu squared, is n times p times q. So 30 times 0.56 times 0.44. So the previous answer times 0.44. And I'm going to give it, well, I won't round it yet, 7.392. Standard deviation is just the square root of your variance. Square root 7.392. And it is approximately, I'm just going to say 2.7. Okay. So what does this mean? It means on average, there are how many cloudy days in June? 16.8. So on average, there are about 17 cloudy days. The standard deviation means 68% of the time in June, we're going to be either plus or minus 2.7 from that mean. And then 95%, we're going to be plus or minus 2 standard deviations from the mean. Now, this problem says unusual values. Do you remember unusual values are how many standard deviations from the mean? They are 2 standard deviations from the mean. So I'm going to take my 17, I'm going to add on 2 standard deviations, and I'm going to subtract 2 standard deviations. We did this before in our last chapter, chapter 2. 17 plus 2 standard deviations gives me 22.4. 17 minus 2 standard deviations gives me 11.6. So what would be unusual in June? How many cloudy days would be unusual? 8. Okay, anything less than probably 11 if we're going to round to the nearest whole number, right? Anything less than 11 would be below 2 standard deviations. And anything more than 22, so 20, yeah, that would work. Actually, I should probably say less than 12 if I want to be right, because we're not going to have 11 and a half. So 11 or less, 22 or more than 22, 23 or more. All right, that's it. That's it for the whole chapter. We're done. All right, so dates, deadlines, things to know. 4.1 and 4.2 Math Excel are both due on Sunday nights. The Chapter 3 test, which you guys have the review for, that we're going to go through tomorrow together, is Monday. The Chapter 4 test, which again, we're going to go through that on Tuesday together, and you have that review, is on Wednesday. Both of those you will be able to use your graphing calculator for. Also, remember, you have a bonus circuit training if you want to do it. Optional. It is due tomorrow in class if you want an extra couple tickets on your Chapter 3 test. All right? Questions on any of that stuff? All right, so tonight you can be working on Math Excel. You can finish up the circuit training. You can try some of those test review problems ahead of time, and then we're going to go through them together tomorrow. Cell phone lotto. Winner is 8. Nope, it'll be today. All right, last 10 minutes are yours.